Good day, everyone, and welcome to this episode of the Innovator podcast. Today, I'm really excited to introduce a brand new innovation to our listeners. We're going to be talking about Smart Composites. Joining me today, I've got two industry experts. I've got Pedro Bordieri from CSNRI, a Henkel company, who's going to be our expert talking about engineered composite pipe repair and talking about the new technology that you've likely not heard of before, Inductosense. I've got Tim Coope with me from the UK. Today, we're going to take you on a journey of innovation where we take two technologies, combine them into something new, and really give you some new and unpredictable outcomes that I think can really transform asset management inside of your industrial facility. So, apart from the introductions, gentlemen, welcome to the show.
Thank you. Great to be here.
So,
thank you for the invite, Don.
Pedro, let's start off. Our listeners have heard us talking on multiple episodes about engineered composite repair, but let's start them off talking about and reminding them about what engineered composite repair is and the fundamentals of how it's used with pipe repair. So can you give us a reintroduction to the technology that some are used to and some are maybe hearing about for the first time?
Of course. Yeah. So engineered composite repairs, they're designed to bring back full operational capacity of a variety of assets, including tanks, piping, that serve a variety of industries. So with engineered composite repairs, we're able to keep important assets going in critical infrastructure in a way that is recognized by international standards and with known engineering concepts that are ultimately reviewed and approved by our customers, the end users.
Okay. So when you mention international standards, can you just remind our audience what a couple of those common international standards are that different clients are probably referring to when they're considering this?
Of course. So we have two main standards. That is the ASME PCC2 and the ISO 24817. And these are internationally recognized standards that provide guidance on how to engineer composite wraps, how to test and qualify them, and the design decisions that are made during the design process. So these are solutions that are tailored to specific cases. Design packages go out with most of the engineering packages that we do. And I think that composite wraps provide sometimes a cold working alternative with minimum disruption to the lines and to keep equipment running for a good amount of time, depending on the industry. We're able to extend the life of assets until a next scheduled turnaround.
You were talking right before we started the show that one of our operations people have been keeping you busy today with applications. For our listeners, they're mainly in Canada. In addition to those international standards, we've got some unique standards that are locally jurisdictional in various provinces in Canada, all surrounding AB539. Can you speak a little bit about what you know about AB539 in the context of our Canadian listeners and the various jurisdictions?
Yes, of course. So the Alberta Boilers Association created a specific design and qualification protocol that actually follows the standard ISO 24817 with a few adaptations. So it is a very rigorous design criteria that we must submit an entire work package for approval for use on APSA regulated lines.
And a few things have changed with AB 539 for the positive in the last few months. Originally we were lobbying ABSA since I started the company in 2009 to get legislative and pressure authority recognition of these types of repairs. It took us and a whole bunch of industry stakeholders a long time to get there, but 2020, 2021, they came out with the first version of AB 539 that, it started off with some restrictions in terms of what they would allow us to do. One of the most recent restrictions was there was some vagueness in that standard around what we were allowed to do with through-hole repairs. And this past summer and into early fall, they just updated that standard to provide guidance on where and how through-hole repairs could be performed. And that's really, expanded its use case again. And we had clients doing that, and we were doing those kinds of repairs when the standard first came out. And then there was some questions about it, and they paused for a bit. And so, what we're seeing now in the winter of 2024, 2025 is the unleashing of more applications. CSNRI has been a leader in this. They've been part of that whole process for many, many years. Just talk to the audience a little bit about what makes CSNRI stand out in the marketplace from their technical expertise.
Yes, of course. I think you said it yourself, Don. We are not only manufacturing and engineering composite repairs for many different industries all over the world, but also we act as subject matter experts when it comes to composite repairs. And with that knowledge and the over 30 years of industry experience that we have, we're able to act as technical consultants as well for people who are interested in using composite wraps for many different applications. With the industry knowledge that we have, we're able to limit composite in some scenarios where, they cannot be used because it's not a one size fits all. There's a lot of engineering that goes behind it. So I think that what sets us apart is being at that cutting edge of the regulatory requirements for composite usage in the industry.
Yeah, and you've been there through that whole journey over the last 10 plus years, being part of the working group to develop those procedures and to guide ABSA and owners and all the stakeholders involved. So it's been really, really valuable. Now, leading to this new solution that we're going to be introducing clients to, one of the things that I hear about a lot and I've heard about for 25 years with different clients relative to their acceptance or their apprehension around engineered composite repair has been, all right, once you fix it, how do I know what's going on underneath? And, we've seen lots of different technologies that have been attempted to give customers that transparency, that ability to see what's happening. So let's just talk a little bit about, that major concern and what customers have been struggling with, what customers have been wanting relative to what happens after you repair it.
Yeah, from a composite design perspective, one of the design inputs that we use for the calculation of repair thickness is the end of life thickness. And in many different applications, we see that we end up considering that there will be a through-wall leak in certain scenarios, and we design the composite to withstand that. However, there is a pressure limitation when it comes to through-wall defects for composites. ABSA even limits that to 500 psi, which is in line with what the industry sees. But I think that the use of sensing technologies for the metal underneath allows us to be able to do repairs on high-pressure lines with internal wall loss, where we're able to monitor and ensure that pipe is within design conditions. In many cases, because we don't have this knowledge at the moment, some of these composite repairs, they end up being prematurely cut. So I think it's just one more layer of confidence in the technology that we're able to add with the Inductosense sensor solution.
One of the sort of effects of that issue has been, I've seen end user clients who are apprehensive about using composite repairs in their facility because they really needed to have a sense of confidence that they themselves, regardless of the regulatory guidelines, they themselves as an asset management team could really have confidence in what was happening underneath. And it was, what one person told me was, it's great that you can repair it, but now you've made me blind. And that was a client who, to this day has been pretty reluctant to take advantage of composite repairs not because of the issue, not because of the regulatory compliance, not because of the regulator, but because they felt they didn't have a handle on their assets, if they could not inspect the integrity of their systems themselves. And so I think the ability of what we're going to introduce next sort of solves those premature cutouts. It solves some of the regulatory and or pressure authority requirements. But ultimately, I think for most of all of our clients, is it can give them confidence that they can still have a handle on their assets, because ultimately, at least in Canada, the way that facility owners are given license to operate their facilities is something called an owner-managed program, where they take on responsibilities and liabilities and accountabilities for meeting, the local authorities' requirements, and they have a certain level of due diligence, which means, they can't be blind. They need to be able to demonstrate that they are constantly managing and monitoring the quality of all those pressurized systems. And I think what we're going to talk about now can really unleash their confidence and their ability to actually leverage this technology, which will then give them a new level of confidence and actually a new way to manage their assets. So let's pivot now, and we're going to talk about the next piece of this innovation puzzle, which is where Tim Coope comes in. Tim, let's start off, and for most of our listeners, they're going to be unfamiliar with who Inductosense is, and so could you just give us a little bit of a sense on who you are and what's the innovation you're bringing to the market?
Yeah, sure. We've developed a unique ultrasonic technology. So it's a sensor technology, and the main sort of ethos behind that is to enable thickness monitoring in a very simple and easy to use system. We refer to it as WAN, so wireless and non-destructive technology, and we're now at a scale where we are deploying tens of thousands of sensors per year to predominantly the oil and gas industry, but also new markets as well. So the ultrasonics are ultra low profile, so just over a millimeter in thickness. And the novel part for us is really the connection between the handheld or the remote data collector with the sensor itself. So it's a bit like wireless charging on your phone. You've got one antenna on the device, you've got the sensor, you align the two together, and simple press of a button will pre-program with the remote data collector. Within a second, you can get that A scan on the screen. So it gives you full visibility of the thickness. And we're using that wireless inductive coupling, which is unique to us, to transmit the data, so the thickness data back to the devices. So that's sort of, we are positioned in the market to be very cost effective. And also one of the benefits of the ultra thin nature of the sensor is that it can be embedded underneath coatings and composites as well. So that's really sort of it adds value to both the composite product, but also, it gives visibility to the users on site of being able to monitor for that thickness.
So I'm not a thickness UT guy, but I am a ultrasonic bolt stress guy, and I've been doing ultrasonic bolt stress elongation measurement for about 30 years. I started off as a bolting technician, so I'm familiar with piezoelectric probes and connecting it to the instrument and all of that. If I can dumb down what I heard, you've got a thin sensor that is permanently, semi-permanently attached to the component. It's super thin. It's where the ultrasonic signal, or whatever the technology that you've developed, is embedded. But there's no cable, so you can effectively be disconnected and have a handheld device that is monitoring and activating that sensor. Is that, in a nutshell, the real?
Exactly, yeah. So we're not changing the principles of ultrasound. The physics are out there. For us, it's really the connection piece. So
right.
By having the sensor wireless, we can have coatings in between, so both viscoelastic coatings and composite repairs. So we can really have that wireless connection to sensors that are not in direct contact.
So some of our listeners are familiar with some of the corrosion under insulation technology that we've talked about on the show, where you've got a certain standoff distance that electromagnetic, generally remote field technology, can use to detect surface corrosion under insulation. What's the standoff distance that you have between a sensor and the handheld device typically?
Yeah, so we're monitoring for internal corrosion. So the sensor's installed on the outside of the pipe or the tank, it's pulse echo into the structure to determine that thickness. So the sensor's installed on the bare metal. Once you wrap that with your materials, so insulation layer or composite, you can achieve up to 4 centimeters reading distance. So standoff distance between the sensor and the device can be up to 4 centimeters.
Okay. But wireless.
Mm-hmm.
Okay. And any guidance on what thickness of material you can effectively read through in terms of the substrate material?
So in terms of the metal, we can read down to 3.5 millimeters and up to 150 millimeters. So quite a range.
Pretty thick.
Generally, as long as it's sort of a non-metallic coating, we can read through up to sort of 4 centimeters, 40 millimeters in thickness. So it really, provides that accessibility to points that otherwise would not be accessible when you have the coatings, especially bonded to the structure as well.
Now we're going to talk about how this comes together to really create a novel, innovative solution that solves a lot of issues for clients. But I've got clients who have armies of UT people who are deployed to take hundreds of thousands of manual measurements per year, really labor-intensive stuff. This could turn that on its head.
Exactly, yeah. And that's what we're seeing. A lot of companies have a digitalization strategy, and it's really, freeing up that labor resource, which, is becoming more scarce. And so, it's really, we've developed the technology to be very simple and easy to use, very quick to install as well. So once that sensor is embedded, it literally takes a second to take a reading.
Right.
There's no calibration required. It is very easy to use. So it does support sort of resourcing sort of current NDT expertise as well, so they can focus more on advanced techniques. So our technology, our one technology, really is part of the toolbox. So we're not replacing people. We are supporting the industry, and being able to provide accessibility where locations that might have needed scaffolding before, you can use one of our remote data collectors. For buried pipe applications, we've got solutions for that as well. So it's really supporting the industry to make thickness monitoring and those thickness measurement much more cost effective, but also sort of relieving some of the manpower required to take those measurements.
Right. So I can envision multiple sensors around, in an array around vessels, around piping, to give customers all of this, particularly where they, looking at the piping behind you in your backdrop, and that's the kind of images where there's dozens and dozens of kilometers of piping like that clients are sending out, like 20, 30 UT technicians to take hundreds of thousands of measurements on an annual basis, because they're getting various predictable but trendable, but not necessarily predictable in the locations where they're going to get failures. So I see this as certainly a way to deploy those resources way more cost effectively, way more productively. But you mentioned a few other application innovations around underground, remote. So, you have the ability, and where it's a challenge to get a person or a wand, the collection device, you have the ability to do some remote monitoring and set up some things. So can you just touch on that a little bit?
Yeah, of course. So, the sensors themselves, they're not specific to a certain data collection method, so it's very universal. So you can either use a handheld device or the remote data collector. So the remote data collector can be installed in the field. It's ATEX intrinsically saved, so it can sit there. You can set the schedule to take a reading, so it could be every day, every week, every month, depending on your frequency. And that data would be stored on the device, so it's there. You can download that via Bluetooth, but we also have further wireless communication as well. So by gateway, so we do have the capability to actually get that thickness data directly into the software without anyone going in the field. So it is, real-time monitoring where needed. So as soon as those data points, those thickness measurements are collected, it can automatically go up to our clouds and be accessible from all around the world.
Literally turning condition monitoring into the smart home.
Mm-hmm.
Fantastic. All right, guys. So we've got these two components. One that we reintroduce people to around composite, that lots of people, I think, I'm biased because I've been doing it for 30 years, but I think lots of people know what engineered composite repair is. They likely have just heard about Inductosense and the wand technology. Now let's bring it together in a unique application that you guys call Smart Composites. So who'd like to, let's start with Pedro and give me your perspective on how this is a game changer for clients relative to everyone who either is or could be using composites in the traditional approach today. And then we'll go to Tim and sort of get his perspective on what this does.
Yeah, absolutely. I think that the game changer here is really, it really comes down to end of life of the repairs, right? It is a very important data, and is a data that is crucial on the design stage, that we know estimated pipe remaining wall at the end of life of these wraps. We make conservative assumptions, sometimes based on UT data that is not very repeatable or reliable. So we end up kind of doubling down on this scaling of internal corrosion progression, which, like we already talked about, affects the longevity of these composite wraps, because depending on pipe diameter configuration, you may really go blind once you put in a composite wrap. So what we've studied with the Inductosense solution is a way to allow us to get repeatable thickness data that we're able to accurately predict when this pipe is going to reach the minimum wall as called for in the design package. There have been a variety of tests done here internally, so we ensure that the technologies are compatible, right? So there has been short-term burst tests with the Inductosense sensor underneath the composite wrap, as required by the ASME ISO standards. We have also done energy release rate tests, which is basically a measure of leak sealing capacity of composites with the sensor installed right on top of the hole. Because the concern was, the sensor has its own adhesive. It's not the same like the composite repair, right? So we had this initial concern that it might affect general composite performance, but through testing, we determined that it does not. So we are able to still put in a quote-unquote defect underneath the composite, which is the sensor, without affecting its performance.
Excellent. So you're not only combining it, but you guys have taken the time on your due diligence to really make sure that it performs as expected. Tim, how about you? When you think about taking your technology and combining it with CSNRI solutions, what's your perspective on how this changes the game for clients?
I mean, there's historically there's been a philosophy that the composite repairs they're a temporary repair, they're a quick fix. You might need to repair a pipe quickly during shutdown or actually in service. So it's really also supporting that change in mindset to actually consider composite repairs as more permanent solutions by actually being able to accurately know the thickness of the pipe that the wrap is bonded to. You can have much more information. You can plan for maintenance periods. So where in a turnaround you might be scheduled to cut out this pipe and replace it with new metal. By actually having that data that's accessible, so really digitizing the whole thickness monitoring process, you're much more informed. So again, it supports other maintenance effort to you don't need to replace this bit of pipe. You can potentially relife the composite by adding extra layers. So it's really having much more informed decision to effective planning so that you maintain the safety of that wrap and the performance by having this extra information. But long term, we've seen in the field that wraps can last 15, 20 plus years. But it doesn't necessarily have that supporting data behind it. So actually by having sensors underneath, you have that data available to accurately predict and further extend the composite repair process.
When I think about it, I see we've been working with CSNRI for a long time as supplier, installer, contractors to bring the composite solution to clients. And what I experience around not having this type of a solution are a few things, right? I mentioned one, which is confidence, client confidence to be able to make decisions. But equally, sometimes the confidence in the decision-making that they're looking for is, getting them beyond the thought process of, do I make this sizable investment in a composite repair so I can get 6 months to my turnaround, and how do I sell that to upper management? Versus, now I've got a solution that can really give a value proposition to my upper management that says, let's not talk about a 6-month plan. Let's talk about a 2, 3, 4, 5-year plan that has the ability to even extend that further. And it can really change the conversation in terms of the way that oil and gas and energy companies make decisions around this in terms of how they're making the deployment of maintenance capital in a different way, because the conversation often is around, help me get to a turnaround so we can have all of this piping replacement in a turnaround window that they already have packed too much with too much cost and too much critical path. Inevitably, as the turnaround gets closer, management steps in across the broad spectrum and starts cutting budget or starts cutting scope, and things get deferred, and all of a sudden that makes things more tedious. The other things I see is, CSNRI and Innovator have one client that for the last 3 years have had some 36-inch extraction piping that we've been constantly wrapping sections of, and Pedro was talking about getting good quality and consistent UT readings as part of the decision making before you do the install. That has often led to weeks or months of them trying to get those things done so they can make, engineered, life sorts of decisions. And I think this can maybe change that sort of the speed of decision making. And then ultimately, I think I think listeners who are facing these challenges are going to be able to make a lot more better, faster decisions, better capital decisions, and do so with a lot more confidence. I think the other part, to Pedro's point, is sometimes you have repairs where the customer needs to sell a package to the pressure authority in terms of, their plan for managing the integrity of this system that is already failing. And I think this solution can also really provide a lot of fortification for the applications for approvals to the pressure authorities to go, now we have this extra level of capability that not only are we mitigating how long we're going to use this repair, but we have effectively the real-time ability to monitor all of these defects to see how they might be expanding. So I think there's an array of really positive changes that this can bring for clients in terms of all the things I mentioned. Can you guys share some, without naming customers, can you share some examples of a challenge a customer had, you deployed Smart Composites, and what kinds of value that created for that client? Pedro, you want to maybe weigh in on that? Just a couple of high-level case study ideas?
Yeah, of course. So just this morning, I was working on a project for a customer in South America where they have a high-pressure pipeline, B314, that has internal erosion. So they give us a millimeter per year loss rate. And with that, we're able to say, okay, you extrapolate that by 2 to 5 years, and this is all you get. So I think that, there has to be a discussion on installing composite or smart composites in this case. So we have full confidence that this repair is operating within design conditions. And especially when it comes to erosion, because, once it goes through a wall, I don't think there is enough testing in the industry out there to support a composite being, high abrasion resistance that is required for this application. And on top of that, this is also a design for over 2,000 PSI. So we must not let it come to a leak. Because the composite will fail at the bond line, So instead of proposing a repair that is short-term, that they're going to have to excavate, install just to excavate and replace it a couple of years down the road, I think that this solution could be, a game changer.
Incredible. And I agree. Tim, I see what you guys have done as, I think most listeners have some level of smart home technology where they have sensors and they have automated controls. I'm a bit of a tech geek. My whole house has things that are going on and off automatically all the time and giving me information. I'm opening doors and garage doors when I'm on the other side of the world and controlling temperature. I think this is just the industrial version of that in terms of let's stop doing things the 1980s way and start really capturing some real value with innovation. What do you think this is going to do for enhancing the push towards smarter data-driven asset management with facilities?
We see that from our wide global customer base that people are looking to digitalize, asset management. There are systems in place, and there is across the industry consolidation of those systems. So to support that, people are digitizing the inspection methods. We started out with our deployments 2019, 2018, 2019. Since then, we've started off with a few hundred sensors a month. We're now deploying thousands of sensors, and there's really great traction across the industry, oil and gas, renewables, to digitize and removing people from hazardous areas, alleviating the cost of scaffolding. So really, making the inspection process much more cost effective as well. But it's not only that, it's, the collection of data and digitizing it, but also the accuracy and precision. So by having sensors that are permanently installed, they're not moving around, you don't have the human error of someone calibrating a UT device, variability between devices. And we've seen that from our customer data. And actually by having the remote monitoring, there's a lot more data out there. With digital twins and other analytics, AI, the industry is really, there's a huge uptake in these types of technologies. So it's really not only, supporting the industry and moving away from manual inspection, but also it's the quality of data and, also the data flow as well. Historically, it might be thickness measurements that are written down and then manually transferred into systems. So for us, it's also supporting that data flow. So you digitize the process, and then that data by APIs and other software integration, we can get that information where the customer needs it and utilize it in their systems. So it's all about efficiencies, driving production as well. I mentioned before the real-time monitoring. So we've done a recent pilot on a well pad application and found that by utilizing the one technology, so very easy to install, you don't have to have that labor on site to take those thickness measurements, but also they were able to achieve a 50% increase in production. So you look at the numbers, they got lots of zeros on them. So again, it's not just the direct impact of different ways of taking the thickness data, but it's also how you utilize that data and supporting the industry for wider adoption. So there's still huge potential. It is still the industry is still adopting these technologies, and it's really great to be working in the industry and supporting our customers for them to achieve their digitalization activities and goals.
Yeah, I agree 100%. I'm going to add on one more thought on where I think this will go. I'm a bit of a visionary, and I can look ahead. I tend to look ahead, but I want to go to Pedro for a second. And Pedro, can you share, either your own personal or CSNRI Henkel's sort of big vision for how does this play into your business value and your business growth? Where do you see it going?
Yeah, so I think the idea is to always add value to our products, right? So, I've personally worked with Inductosense over the last 6 years or so. And, I've installed Inductosense sensors, and I know how easy it is to install it, collect the data. So I think that, is just another thing that we are, innovators, pioneers at heart. So I think that this is something that we see a lot of synergy. We understand the market demand for it because we are, talking to customers every day, and, these things are repeated. So once the Inductosense, technology was shown to us, shown to the team, we went to work. We started testing, qualifying the system as a combined system. So I think it just adds a lot of value to our composite solution offering that are highly engineered, and now we're entering the digital space as well.
Yeah, I think we've got 6 or 8 of our technicians trained to install Inductosense sensors now as a result of some projects that we've done together. And, our team was really impressed with just how simple and easy it is. It's really a very novel solution to what some people traditionally have overcomplicated, and particularly, I'll reiterate what Tim said around the risk of inaccuracies relative to ultrasonic calibration by individuals and across instruments and across any temperature fluctuations. I'm behind me on my shelf. We're talking about digitization. I remember doing UT reports where my UT device used to produce a little cash register receipt of the measurements, and then you had to literally either manually enter that into some sort of a database spreadsheet before even Excel. This was like 1994, and or or the simpler version I saw some people doing was literally taping the ticker tape to a piece of white paper and then photocopy it and then having that tagged on to the turnover package to the client. Literally, you'd have to physically look to see if what you were, looking to verify was in compliance. Lots of people didn't because it just became redundant paper records that provided no value. We've been on a journey at Innovator since 2012. I think we were relatively ahead of the curve, particularly in terms of contractors, with a drive and a push to digitize our entire business. And so our entire business, almost everything we do, from sales, operations, marketing, safety, quality, finance, it's all interconnected and it's all cloud-based. And it becomes, and it was really, we started that journey anticipating what AI was going to bring to having good structured data. Here's my prediction for this solution that you guys have brought is I think over the next 12 to 36 months, customers are going to be able to use the data that is being collected to do better predictions on the trending of their assets in a way that they had to do manual calculations on that were often very conservative in the past. And I think it's going to create new levels of insight, leveraging AI, that is going to help them make way better decisions well in advance of asset replacements. That's my prediction. Is where this goes, AI is going to make it exponentially stronger in terms of its value. As I said, we've been digitizing for a long time. We're not a huge company, but I've got 2 people on my team, and their whole job is implementation of AI across the business, wherever we can use it to automate, to improve workflow, to make predictions, and to speed up productivity. I can guarantee you all of our joint energy clients all are on that journey together. And whenever you can give them structured quality data, it's an obvious place for AI to take it to the next level. So, I might be wrong, but that's what I predict customers will be able to do with this after they deploy it and as they start seeing it. And so, what I'll say to my customers is, let's go install 10,000 sensors in your plant. and
let's do it. Yeah.
Right. So I think this is a really novel, and unpredictable solution that I think is going to have really positive and probably deceptive value for customers, well beyond the decision to do the first 100 sensors, the first pilot project. I think this has incredible exponential value. So that's my take on Smart Composites and all of the other use cases that I think Tim touched on just a little bit, that are even beyond whether it's under a composite repair, because it can be under insulation, it could be under paint, it could be exposed on the side of a pressure vessel where you have some concerns of risk or bulging, or all sorts of places. I mean, some of the biggest fires and explosions and incidents that I've seen some of my clients have over the last 20 years is some piece of piping that they didn't have the ability to monitor very well, and it went pop in the night. And, this can eliminate some of those hard to reach, inconvenient, difficult places that customers have unaddressed risk. So any closing remarks, gentlemen, on what you think where the industry is going with these kinds of technologies, and maybe any other novel ideas on how it can be applied before we wrap up?
Yeah, I think you brought a good point, Don, about predictive maintenance. I think this is a hot topic right now. Composites are historically a reactive solution, right? Your pipe springs a leak, you go there, you stop cap it, or you shut it down, install a composite wrap, and then you keep it running for, like you said, 6 months. Oh, we need it until May. But I think that with this new solution, I think that we're able to, if we install the systems or the sensors, I should say, before it gets to that problem, when you're approaching T-man, you can design a composite wrap to absorb those loads, keep pipe operational, and extend it until it reaches a critical thickness. Some cases 80%, some cases 1 millimeter. So I think that changing the use of composite wraps from a reactive situation to a remediary situation, I think that this, at the end of the day, ends up making the whole process more efficient. The more conservative you are, the more layers of composite wrap you need to install. So that just drives up the cost. So you have smarter data, so you can make smarter decisions that will end up, at the end of the day, saving a lot of money and time.
Yep. Tim, what do you think? Any other closing comments, and any other roadmap ideas on where you're going?
Yeah, I mean, for us, really, it's not just the accessibility piece of, we can't get to that pivot pipe or, area of tank. For us, it's really the accessibility of technology to our customers as well. So, our system is very cost effective. So, people can replace all of their thickness monitoring locations with our sensors because it is such cost competitive. And, we have various different offerings to support that as well. So for us, it's really seeing our customers, not just with, tens, hundreds of sensors, it's thousands, tens of thousands. So they see the value, and they have the return, and they can better support their operations and make their facilities much more efficient as well. So for us, it's really accessibility to technology at a very cost-effective level. So, there's low entry to market, but also, the value that brings to the customer is huge, not just in just the quality of the data, but how they can utilize that data to support their operations as well. So, yeah, from my side, from Inductosense, it's really accessibility of technology, and also providing very cost-effective products to the market that could be easily implemented as well. And that's both, adding value to composite products and other coating materials as well. So the customer sees benefits of not just innovative materials, but also innovative technologies as well.
Yeah, I've got inside of our business, our purpose is to use innovation to create value, and that's innovation in delivery, innovation in technology, with a goal to do three things: improve safety, improve productivity, and improve cost effectiveness in ways that customers could never predict traditionally. And innovation, is a cool buzzword. Most people don't know what it means. They confuse it with invention. I think the most elegant definition of innovation, and this is the Industrial Innovators podcast, is, if you have two solutions, two technologies, two products, most people will go, oh, cool, 1 + 1 = 2. But the reality is that innovation is combining two or more things that creates a completely new value proposition. And And so, the product, I call it level 1 value. The service is level 2 value. Outcomes is level 3 value. But the value that true innovation brings is transformative value, level 4 value, which can transform the way a customer does business in ways that are not even directly, attributed to the solution itself, but the entire model of how they do things. And if this is a technology combining this innovation, I think has the power to rapidly transform our client's business model in terms of the way that they do asset management. And I think those are, that's the force multiplier here. This situation of 1 + 1 is not 2, it's not 3. I think it could be 10 or 15x in terms of the value that it can bring to the clients who decide this is the way they want to go. And so, I like I said, 15x force multiplier is my prediction. So there you have it, gentlemen. Pedro, Tim, really want to thank you for coming on the show, allowing us to be able to have this conversation and tell the story so we can get this out to our audience, to our customers, and hopefully this recording will be that force multiplier that helps one of our clients, and then 10 of our clients, and then 100 of our clients take that step to use some transformative innovation. I really appreciate you guys being here. Fantastic.
So much for the opportunity.
Thanks for having me.
All right, back to Houston and back to the UK and here from Edmonton. We're signing out. Thanks very much. Thanks everyone for listening. And if you want to talk about Smart Composites or you want to get in touch with anyone on the team, reach out to us at Innovator. We are partners with Clockspring and Clockspring. You guys keep having new names. CSNRI, Henkel. I've been working with you guys a long time. We're partners with them in Composite. We're partners with them in deployment of Smart Composite where it makes sense. We've got some of our technicians trained, and so you can reach out to us if you've got Canadian applications. If you want to learn more about Inductosense outside of composites, reach out. We'll connect you with Tim. If you've got solutions where you need composite repair anywhere else in the world outside of Canada, then we'll get you hooked up with Pedro. So all of us are here to help you, whether you're in Alberta or you're in Guatemala or you're in Saudi Arabia. We will help you take advantage of this technology and help you guys transform. So thanks for listening, everyone. Gentlemen, thanks a bunch. I really appreciate it again.